If you're not already in your notes, but it looks like most of you are, go ahead and get in there. So the second page, after you get past the video material, says critical numbers are, C is a critical number if f prime equals blank or if f prime is blank. Again, this is a review from 4 minutes ago. F prime has to be either 0 or undefined. Yep, so f prime equals 0 or undefined. That's what makes a critical number a critical number. And we'll continue to kind of explore what that means with graphs and such. And then there's some guidelines right here. I tend to not read these boxes simply because you can read them just as well as I can. I tend to just want to show you how to do it, and then if you want to look back at these steps and say, oh, now the steps make sense. But at this point, I don't know how much sense the steps are going to make. So let's move on. Let's move on here. Let's take a look at example number 2. We are going to jump around a little bit here. We're not going to start with example number 1. Going to kind of scaffold this for you, hopefully to be as easy as possible coming in. Okay. All right, so let's see here. Let's make sure we're clear on what this is. So number 2 says find the absolute extrema of h of x equals, and it gives you this function. The word absolute could also be interpreted as global. And I want to give you just a brief illustration of why maybe that word is also important to consider. Then all this stuff would be out, and we'd kind of have to look at a different type of extrema. But because they are brackets, it does include the endpoints. And so that's a hint that we are looking at global extrema, beyond the fact that it says find global extrema. So here's how I tend to do these. Let's be really systematic about this. I'm going to first list out my candidates. So I'm just going to literally write the word candidates for my absolute extrema. And 2 of the candidates take absolutely no effort whatsoever. What are they?
Negative 4.
The endpoints, right? Yeah, negative 4 and 4. So candidates would be x equals negative 4 or 4. And so we might stop and say, hey, that's it. And it might be it. But we also have to consider those possible turnaround points, right? Where we have the horizontal tangent lines or the points where f prime doesn't exist. So those are called critical numbers. So your candidates are, we'll rehash this over and over and over until everybody gets it. The candidates for absolute extrema are endpoints and critical numbers. And critical numbers are places where f prime is 0 or doesn't exist. Okay, so if we're going to find out where f prime is 0 or doesn't exist, or in this case, h prime is 0 or doesn't exist, we probably ought to be informed about what h prime actually is. So let's go ahead and figure that out. H prime equals, let's do some differentiating here to wake ourselves up. Lauren, you got it?
Negative 3x squared plus 6x plus 9.
And of course, derivative of minus 8 is just 0, right? Perfect. Okay. So the next thing we're going to want to do is look at this just with sort of an educated eye and ask ourselves, is there any conceivable way that that won't exist? No. What is that? If we were to graph that h prime, what is it? Parabola. And parabolas exist for all x, right? It's a polynomial, so it's continuous everywhere. There's no points of discontinuity. So I think the whole f or h prime not existing, that's going to come into play sometimes, but it's not going to come into play here, so we just ignore that part. Does that make sense? You have to always at least mentally think, might this not exist? And if there is that possibility, you need to figure out where it doesn't exist. But if it's always going to exist, then you just move on. So here's the next thing I'm going to do, and I'm going to highlight this for you. Equals 0. This is a really important notation. It's an important transition because we're going from just some h prime equation to making it equal to 0. That is something you most definitely need to write down on your paper. Don't just think it. Don't just type it into your computer.
Go like that.
Of course.
Does it have to be?
No, that's beautiful. Don't just type it in your calculator or graph it on your calculator, which is a possibility. You absolutely need to write that down. So please do. Okay, so I just set h prime equal to 0, and now I'm going to solve. There's a variety of ways to solve this, one of which is certainly to just use the calculator, but let's go old school and let's factor and solve this. What would you do if you're going to factor this? What might be your first step to make it easier? Not just take out, but since it's an equation now, can't we divide everything through by negative 3? There's an important difference. Eventually you would do that, I suppose, even if you did factor it out. So if you do divide everything through by negative 3, you'd get x squared minus 2x minus 3 equals 0. And now it's a lot easier to factor. What would be the factorings there? X with what and x with what? Yep, minus 3 and plus 1. So x minus 3, x plus 1 equals 0. And then we set each factor equal to 0 and solve. We get x equals 3, x equals negative 1. There we go. And so now as far as my candidate list goes, I can fill out the rest of it. My candidates would be negative 4, 4, 3, and negative 1. So those are my candidates for my highest and my lowest possible points. Those are just candidates though, right? There's no guarantee that any one particular one is the max or the min. We need to test these out to decide which one is the max and which one will give us the min. Now the way that I typically will do this is to just create a table. Because all we're trying to do basically, think about this really simply. Aren't we trying to find the highest y value? And then also try to find the lowest y value? And so just doing a little input-output will allow us to do that. So that's what I'm going to do. I'm going to come over here to the side and do a little input-output. So my candidates are in order, negative 4, negative 1, 3, and 4. My outputs will be h of x equals y. So I'm looking for the highest y values, or the highest y value and the lowest y value for my max and my min. So let's get busy doing a little plug and chug, input and output. I'll take answers from you. We are plugging into h of x, right? Because we're trying to find out what is the highest y value, what is the lowest y value. So maybe use your calculators. These numbers are a little on the edge of could you do it without a calculator? I'm quite convinced you could, but it might be a little time prohibitive. I might tread that line tightly at times, but let's give this a shot. Once you think you have an output, let's confirm it and let's get it up there. For the first one?
Yeah.
So 68. Negative 13 for the next one? 19 and then? Okay, let's get some confirmation. Make sure we all agree on those numbers. I did not do this ahead of time. Ben agrees with all those. You guys all seem to agree with each other. Yeah, okay. Cole's giving the head nod. Yep. All right. Let's give everybody just a chance to, let's make sure we get it right. I mean, it does make sense because we have a decreasing cubic, so you'd think that left endpoint potentially could be the highest. It does depend on your world, though, right? Seems to sort of fit, though. That's good. Any disagreement on any of those numbers? Good? Okay, fair enough. I'm just being real honest here. I didn't do this. I haven't done this question in at least 12 months, so I don't have the answer memorized. Okay, so now what we need to do, finally, we need to call out our answer. Like, we need to address the question. And so all you got to do here is just find the highest y value, and that would be, of course, right there. So we could say the max is 68, or if you wanted to say negative 4, comma, 68, that's fine, of course, right? You can give the full coordinate. But all I did really ask was, what is the absolute extrema? So the y value would go with it. Like the highest point is at 68, right? When you're at a height of 68. And then, of course, the min would go with the lowest y value, and that's negative 13. So you could then say the min is negative 13, or if you wanted to say negative 1 comma negative 13, that's fine. But it's the y value we're looking at to make this judgment. We're not looking at the x values, just the y values. Looking for high and low. Okay, so let's finish this off with just one exercise, and then I want to address maybe a possible misconception here. Will you guys take just a second and graph this whole thing on your calculator? Take a minute, and when you do, please use the window button to define your world correctly, okay? So set your window to go from x equals negative 4 to 4. And you should see this playing out, okay? That make sense? I'll do the same thing up here. You give it a shot on your calculator. We'll maybe illustrate a couple things, and then we'll move on. Your window might have been slightly different than mine, but basic plot is about the same. Okay, so then what you can see, of course, is that, yes, I mean, I suppose we've confirmed the left endpoint is the max. Isn't that the highest? And then you can see, like, here is one of the critical numbers, and this one happens to be the absolute min. You can see it because it's the lowest, right? This right here was a critical number, but it's not the highest nor the lowest. And so even though that is an important number, it's neither. And this is the right end point. And again, that's a candidate, but it's neither the highest nor the lowest. And so it kind of falls off the picture as far as maxes and mins. Falls out of the picture, if you will. Okay. Does that make sense? Okay, let me address a possible misconception here that somebody is thinking, oh, I know what I'll do. So in your syllabus, I outlined this for you. I don't remember which part, but I know it's in the syllabus somewhere. In regard to the functions on your calculator that are okay for you to use. You are welcome to use the max min finder on your calculator all you want, but if you do, I will give you no credit whatsoever. Does that make sense? Like on a quiz or a test, of course. Simply because this class is about why is that the max and why is that the min, as opposed to can you push the buttons on your calculator like you did in Algebra 2 or pre-calc or whatever that was. And so you are allowed to use the zero finder or the intersection finder. Absolutely, we will do that very, very soon. You are allowed to use the Math 8 button, which you guys have all used at some point or another. And then later on we'll talk about Math 9, which is another similar type thing to Math 8. Those are the special functions you can use on your calculator. The max min finder, something that, I can't really make you not use it, but I can not give you credit for it. Does that make sense? Use it. If the calculator is active and you choose to use it, that's your business. But if you say, hey, that's the max because I used the max min finder, I will give you no credit. It's very simple. And the funny thing is, like, I've had this conversation, as you can imagine, every single year, yet every now and then somebody will do exactly that. They'll say, I found the max using the max min finder. Like, I told you I was not going to give you credit. There's no loopholes here. There's no like, oh, well, I kind of didn't use it. You need to do stuff like this. Yeah.
We can check our work, right? Like, say we're on a quiz.
Yes and no. Like, if it's active, just know that, like, I totally know about it. And so I very well might put a question like this, what we just did on the no calculator section.
But then if we solve and have the table and just check like each.
But if the calculator is not active, how could you possibly check with the calculator? Does that make sense? Oh, that's the one in your brain. That's right. Peyton. What about a multiple choice? Well, why, just from a strategic standpoint, why on earth would I put this question on a calculator multiple choice question? I wouldn't. So I just gave away the test right there. There is a 0% chance I will put that question on the calculator multiple choice part of a test. There is a no chance. No chance of that. Just saying. Okay, fair enough. Okay, let's move on. Let's try some other stuff here. Let's take a look at number 1 now. Let's go backwards to that one. So you guys have had a good primer kind of on how to do this. So here's what I want to do. I want to give you a couple minutes. And listen, this one is a little trickier than the last one. That's why I put it second. But what I want you to do in a couple of minutes here, I want you guys to, at the very least, have listed out all your candidates. If you have enough time to test them out and decide which one you think is the max or min, that's fine. But in the next few minutes here, I want you at the very least to list out your candidates, and then we'll check those, and we'll kind of move forward from there. Give it a shot. Okay, let's see if we can handle this, see how we can handle this. Candidates for absolute extrema, we're going to include the endpoints. We've got them right there. We'll put those in at the end. But let's tackle the harder concept here, and that is how do we find the critical numbers to fill out our list of candidates. So critical numbers are places where f prime is either or DNE. Yep. So in order to judge that, I need to have f prime, which I don't. So I'm going to find it. F prime of x is equal to 2 minus the 2/3 would cancel with the 3 to just be a 2. And then x to the negative 1/3. And like we did on the previous example, at this point, now that we found f prime, we want to ask ourselves, well, is there any way that this won't exist? So let's ask ourselves, is there any x value that would cause f prime to not exist?
0.
0. Why would 0 cause that problem?
2 over x to the 1/3.
Isn't that a denominator? doesn't a negative exponent indicate a denominator? And so it's really 2 over x to the 1/3, right? So if x was 0, 0 to the 1/3 is 0, 2 over 0, we have a major problem. So what that means then is that f prime doesn't exist at 0, because 0 would cause f prime to have a 0 in the denominator. So 0 is one of our candidates. Pretty simple. It's easy to miss though, right? Really easy just to be like, oh, moving on. So always consider, is there a place where f prime won't exist? Any questions? Okay, well, we also have to ask ourselves, is f prime being 0, is that going to come into play as well? So I'm going to say 2 minus 2x to the negative 1/3 is equal to 0. And this is where the algebra gets a little on the tangled up side, sort of, but we can navigate it. Looking for a suggestion from anybody. What did you, as you try to tackle this, what did you do first?
First thing was I made the second half of the equation make actual sense, so I switched it to 2 minus 2 over x to the, or over cubed root x there.
Over the what? Cubed root of x?
Yeah.
Okay, fair enough. And then equals 0. I don't know if all of you did that or not, but that is a valid step, and I think it makes sense. So if we're going to go from that, what would you do after that, Ben?
I added the 2 over the cubed x over to the right side.
Okay. That makes sense. I like it. What about next?
Start guessing numbers.
Oh, that works.
It does.
Isolate the cube of x, but like, you know that if x is equal to 1, then that
Yeah.
makes it true.
You know, really, honestly, if this were a quiz or test and you got to that point and you just said x equals 1, I'm fine with it. But I'm not fine if you look at that and you're like, I have no idea how to do the algebra. How do you get an x out of a denominator in an equation like this?
Multiply both sides by-
Multiply, yeah, like essentially cross multiply, right? Like multiply both sides by cube root of x. So if you did that, you'd get 2 times the cube root of x equals 2. And now, doesn't it become a little more apparent? What do we do? Yeah, you divide both sides by 2, and you end up with cube root of x equals 1. And how do you get rid of the cubed root? Cube both sides, yep. So we cube this side and so on and so forth. And we finally end up actually confirming that your guess, educatedly guessed answer is correct. X equals 1. Okay. I'm okay though, like I really am okay. Like if you got to this point and you are good enough with the algebra that you can like without a doubt confirm, yep, the only answer that works there is 1. But just be really careful that that's the only answer. Because if it was 2 equals 2 over the square root of x, you'd get an extra answer, wouldn't you? So make sure you understand the algebra behind it, but maybe those last few steps I'm not as concerned with seeing. Yeah.
So if we were to hypothetically do that 2 equals 2 over square root x, how would you go into like doing the table for every negative number, because it wouldn't exist?
Only,
Because like square root of negative 2.
Oh,
doesn't exist.
gotcha.
So how would you do a table there?
well, you'd only be limited to your world, right? It'd only be the,
Yeah, but it's all numbers with all decimals. It's like, is there no?
yeah, I agree. That would be,
Or can you just give us? Some
well, it depends on your, like hopefully, well, let's just be honest about it. Hopefully I would not
Is that not?
I would not set up your world to have negative inputs. Does that make sense?
More test information from Selenol. No,
I would gladly tell anyone all of it.
no absolute extrema on the.
Don't run too far with the ball, though, buddy. Seriously, do not run too far with the ball. Hey, so let me fill this out here. This is where I wanted you guys to get. I wanted you to have -1, 0, 1, and 3. Those are your 4 candidates that you should have. I would say of those 4 candidates, probably the 0 was the least obvious. But the 1 was difficult to get to still. You had to do some algebra to get there. But there are actually 4 candidates, not 2 or 3. Jake, your question.
Can you explain a little bit again how you found 0 to your candidate?
It comes down to this. When you get to this first step, right here, when you find f prime, right? So you just did the power rule or some other derivative rule. Always stop and ask yourself, is there any number, is there any x value that would make this f prime or h prime or whatever it is not exist? So in algebra, the only way that we find things not existing is if you do the square root of a negative, or division by 0. So you'd look at that and you'd say, hey, is there any way I might divide by 0? Well, there is, right? Because x to the negative 1/3 is a denominator, right? It's really 2 over x to the 1/3. So you mentally ask yourself, well, what would x have to be for that to be 2 over 0? 0, right? Like in the previous example we did, when we got to h prime, yeah, h prime was just a quadratic. And so when you ask yourself, is there any way I might divide by 0? The answer is no. There's no denominators with variables. Is there any way I might do a square root of a negative? There's no square roots. And so for that one, the answer to the DNE was no. But this one, you could accidentally divide by 0. So the answer was yes, and it would happen at x equals 0.
Okay.
That make sense?
Yeah.
Okay. Anybody else with a question? Okay, fair enough. Have you guys run these numbers yet? Input, output with f of x? Okay, so what was your output for -1? -5? Okay, yep, that makes sense. How about 0? 0, yes. You plug in a 1, you get 2 minus 3. So you really only needed the calculator when x was 3. So that came out to be some crazy decimal, right? Negative 403. Okay. You guys agree with that last number as well? Okay, so now you call it out. Real simple, you just say the max is 0 from this 0 right here. And the min is -5. Sorry, that kind of ran off the screen.
And you don't have to show the x values?
Oops. You don't, unless asked for. There we go. And sometimes I will ask for them. Sometimes I'll say find the absolute max, x comma y. I'll ask for both. But if it just says find the max, then they're looking for the y value. Okay. All right, question, Matt?
Question about, because we have to find places where the derivative does not exist.
Uh-huh.
So the derivative doesn't exist when there's like a totally vertical slope, right?
Yes.
So that would be a vertical asymptote with both sides approaching infinity.
Yes.
But that wouldn't give you like
Yeah.
a max or a min.
They're just candidates.
Okay.
They're just candidates, right? So they might end up panning out or not. Kind of depends. Okay, so we're going to do one last example. That'll save us for one of them for next time for Monday. So let's look at number, I think it's 3 is what I want to do. Not Monday. A meeting after that. I guess Tuesday it would be. All right, so number 3 is what we're going to do. Let's try to sum this up and kind of work through this one together. I think for the 5th or 6th time today, I'm going to ask you, we're looking for absolute extrema. What are the candidates for absolute extrema?
Pi over 8, pi over 4.
Oh, I'm sorry, in general. In general.
Critical points.
Oh, we're totally butchering this. The candidates for absolute extrema are endpoints and critical points. Endpoints and critical points. Those are the candidates for absolute extreme. Okay, so the endpoints are pretty much always given to you. It takes no effort. Just got to look at them, and there they are. The critical numbers, the critical points, that's where we've got to put in a little bit of work. Now here's where we take that next little step in logic. Endpoints are just given to you, but where do we get critical numbers from? Equaling 0 or doesn't exist. That's right. So in order to calculate that out, we need to actually have f prime, and we don't. So we need to figure out what it is. Johnny, what do you think f prime is for this one?
Sine 2x times 2.
That is masterfully done. Right? Negative times negative is a positive. He did the chain rule correctly, right? That's where that extra 2 comes from. Perfectly done. So let's ask ourselves the same question we asked last time. Is there any x value that would cause f prime to not exist? Bianca, Hannah, Cole, Peyton, Eliza, Lainey, any thoughts? Any x values that would make f prime not exist? It's just a cosine graph, right? Or sine graph. Sine graphs just do this forever, don't they? So it's going to exist everywhere. So the whole DNE thing does not come into play here. So we leave it alone. But equals 0 definitely comes into play. And isn't this graph going to potentially equal 0 a lot of times?
Infinitely.
Infinitely many times, right? But we're restricting our world to just this little part of it. So let's go ahead and go through this. I would divide by 2 to start off with. Sine of 2x equals 0. What's my next step? Ouch. It's quieter than I thought it would be. Say again? Yeah, unit circle could come into play. I agree. But how do I get rid of sine? Inverse sine. Yeah, so what I do here is I just do inverse sine of both sides. So that means that those two things cancel out, right? The inverse sine of sine cancels out. So all I'm left with here is 2x equals the inverse sine of 0. And this is where the unit circle comes into play. You're essentially asking yourself, what angle has a sine of 0? What do you think? 0. So 2x equals 0. Where else? Pi. 2 pi, I'll put dot, dot, dot. If we need more, we can do more. But to actually solve for x, what would be my final step? That's right. So we divide by 2, we get x is equal to 0, pi over 2, pi, bless you, dot, dot, dot. So how many of those actually fit within our world? I think just pi over 2 fits, doesn't it?
Yeah.
I think the other two are outside of it. So even though those are places where f prime equals 0, it's not within our domain, and so we just leave them out. The final step then, of course, is to take your candidates, which would be the endpoints, and the lone critical number. This time we only had one. We take those candidates and we evaluate them using a table. Whoops. There we go. So pi over 8, pi over 2, 3 pi over 4. This is very doable with just using your unit circle skills. We are up against our time though. So whether you use the calculator or unit circle skills at this point, I don't really care. But know that you do need to know how to do the unit circle. And all these would be, I think, all of these, yeah, but times 2. When you plug in, it would be 2 times pi over 8, which would give you pi over 4. So let's see here. Let's do these real quick. This would be negative 1 over root 2. When you plug in the pi over 2, wouldn't the 2's cancel, giving you just cosine of pi? Those 2's canceling will be a big deal. So cosine of pi is negative 1. The opposite of that is 1. And then you plug in the 3 pi over 4. The 4 and the 2 would cancel to give you 3 pi over 2. The cosine of 3 pi over 2 is? Zero. Whoever said that is right. Yep. And the opposite of 0 is still just 0. So the max is 1. The min, negative 1 over root 2. Okay. When I see you on Monday, it will not be in here. Have a great weekend.